So welcome everybody to our latest edition of Upgrade and Migration Office Hours. We decided to have a brief topic on fallback strategies today to start this set of office hours. And let me go into full screen mode for that. And at the end of our little presentation on fallback strategies, we'll address the questions that were sent in earlier and then any that come in on chat. So if you do have any questions, please feel free to enter them in the chat window. So my name is Roy Swanger, Vice President for Database Upgrade and Utilities at Oracle. Also with me today are Mike Dietrich, our Master Product Manager, who many of you know from many events and interactions, and Bill Beauregard, our Product Manager for Utilities and Data Pump. So today's topic is fallback strategies, and this is one that comes up with most major customers who are performing upgrades. It is very important to have a fallback strategy when you start an upgrade or migration, just as it is on any major change to the database. You want to have a way to go back to a known good state. So baseline is that having a good RMAN online backup is absolutely essential. And let me reiterate that RMAN is backup. Every so often we talk to customers who are using Data Pump for their backups, or long ago it used to be export import, but really RMAN is a much more robust backup that gets you to the known good state with your same physical database as opposed to the logical export and import that you would get from Data Pump. And even if you have that RMAN backup, the other thing is that we really want you to test it maybe once a year. And that means having to, knowing, well, I think we'll get to that on the next page. But you also need to know what is your fallback requirement. And these can be defined in your SLAs. It can be minimum time to recover, all the various acronyms about that. You want to know how fast you need to be back online after if an upgrade goes bad. You need to think about two very distinct types of issues. What happens if something goes wrong during the upgrade, where you might be just as happy to go back to that point right before you started it? Or what happens if you find a problem several days or even weeks after the upgrade, such as let's just say you have a rarely used application that you didn't realize wasn't certified with the new release, or you have some other remote database that has a DB link to your upgraded database, but it's at an earlier version where the DB link isn't supported. What do you do in that situation? And then think about whether you'll have the additional downtime available to set the compatible parameter. Now, compatible is very important when it comes to upgrades, and it's also a very misunderstood parameter for the database. The compatible parameters function is to govern access to features in the database that change the on-disk structure in your data file. So that doesn't mean that it governs all of the behavior of the database. For example, compatible does not govern the behavior of the optimizer. There are separate parameters for that, such as optimizer features enable. There are also other types of features that simply would not be affected by the compatible parameter because they only act in memory. You could think of something like PL SQL results caching as something that happens only in memory and therefore doesn't affect the online structure of the database. On the other hand, there are some other features such as moving to secure file lobs in 11.1, going to multi-tenant in 12.1, even in memory, the database in memory option, which you would think is wholly in memory, it actually has some on-disk structures that require a compatible setting of 12.102. So anything that affects the on-disk structure of the database may require a higher compatible setting. So some of the considerations about compatible when you're going to upgrade. The first is you need to know what is the minimal supported compatible setting for the new version of the database. For 12C and even all the way up to 18C, the minimum compatible setting is 11.0.0. And this is important to know, especially for those who might have a 10.2.05 database that is going to upgrade to 12.102, or even an 11G database that still is compatible set back to 10.2 or 10.1. When you upgrade to 12C, you will have to change compatible. Now, in many cases, we recommend that you wait to change compatible when you upgrade, because updating compatible will limit your fallback options. We'll talk about this when we mention downgrade and guaranteed restore points. So that's your second consideration, is that you may limit your fallback options if you raise compatible. A third consideration is that you may need to raise compatible if you're interested in some of those new features that require the higher level. If you want to use sharding with 12.2, well, you're going to have to raise your compatible setting to 12.2. And the final consideration is that raising compatible requires a downtime. It requires restarting the database after you issue this alter system command. So that's 4 things to think about with the compatible parameter. What's the minimum compatible for your new version? Do you need the newer compatible setting for the features you want to use? Do you need to not raise compatible so that you can preserve your fallback options? And finally, will you have time to set compatible again in the future by restarting the database? So when people ask us, should I raise compatible during the upgrade, there's not a one-size-fits-all answer to that. It really depends on those 4 considerations. Now, if you have an issue during the upgrade, we have really 3 fallback strategies available for you. There's the online backup, offline backup, or what we call a partial offline backup, and then the guaranteed restore point. And any of these would be a way to recover from, say, a situation where the upgrade simply fails for some reason, such as maybe you had an invalid component and didn't fix it prior to the upgrade, or the system fails, or you run out of disk space, or maybe the upgrade is simply just running too long for your outage window and you realize it early enough that you need to fall back. So let's look at each of these strategies. First is the RMAN backup. I mentioned this earlier as being absolutely essential. Well, even if you have that RMAN backup, you need to make sure that it is usable in a couple of ways. First, you want to make sure that you have a good backup. I have personal experience with this because when my kids were in high school, their high school used a system based on an Oracle database. It was a software system for managing schedules and grades and such. And over one summer, they found that there was corrupted data in the database. Well, they went back to all of their backups and found that all of those backups had corrupt data as far as they had retained them. And the price of not having tested their backups is that they had to re-enter all of the data for every single student in the school over the summer. So it was a lot of extra work because the backups hadn't been tested. The other thing you need to know is how long will it take to restore your backups? Not just doing the restore and recover, but what if your full backups are stored off-site in fireproof storage and it takes you a half hour to drive there, get the backups, and bring them back on site? How long does it take to do your full restore followed by all the necessary incrementals? If you ever have a case where you need to go and restore your backups and recover your database, you can bet that somebody very high up your management chain is going to ask you immediately, how long is this going to take? So you're going to want to know that by having tested it. Now, we also have another technique that can augment your online backups, and we call this a partial offline backup. This takes advantage of the fact that the database upgrade does not touch your user table spaces. You can actually upgrade your database with all your user table spaces set to read only. So if we look at all of the data files in the database, we have our system, sysaux, all the other potential system table spaces, and your redo and your control files and all that. and that is distinct from your user table spaces, your data table spaces. If we set our user table spaces to read-only prior to the upgrade, and then when the database is shut down, we take a copy of all those system table spaces, then if there's a problem during the upgrade, we can simply shut down immediate, copy all of those system table spaces back to their original location, and start up under the old software version. This will work because with those user and data table spaces set read-only, we won't update the data file headers. We won't change the compatible within those data files because they're read-only. So this is a really useful way to get back and running pretty quickly, because generally all of those system data files are much smaller than the rest of your database. If you've got even 100 terabyte database, you're going to be in the hundreds of gigs of system sysaux and so on. A second method, or the third method for falling back if you have a problem during the upgrade, would be a guaranteed restore point. This is the flashback database feature that was added back in 10.2. So any database that is upgrading to 12c can set a guaranteed restore point. The main restriction on guaranteed restore points is that you can't change compatible in order to use it. That means that you won't be able to implement the new features right away, but a guaranteed restore point is a very quick way to go back even to an earlier version. We would start before the upgrade by creating a guaranteed restore point, as you see in the upper left here, create restore point, guarantee flashback database. Then you would perform the upgrade, and you could even do some initial testing after the upgrade, doing anything you want as long as you don't raise compatible. And then if you find that you don't like the new situation, maybe the optimizer isn't treating your query plans well, or something isn't working even though you've tested it, you shut down immediate, start up in mount mode, and flash back to that restore point. In my experience, flashing back an upgrade takes just a few minutes. Even for an upgrade that may have taken 45 minutes or an hour to run, you may flash back in as little as, say, 3 to 5 minutes. And then you start up in mount mode, open reset logs, and then after you open the database again, you would drop that guaranteed restore point. The reason you do that, by the way, is that once you set a guaranteed restore point, we will track all the changes in the database in the fast recovery area. And if that fast recovery area fills up with changes, the database will stall until you either add more space to the fast recovery area or drop that guaranteed restore point. So, and Mike makes the point in chat that flashback database does not work with standard edition. So that's useful to know. Thank you, Mike. Now, what happens if you have an issue after the upgrade? And again, I've had some experience with this long ago, almost 15 years ago, when I first started managing the upgrade and utilities teams. One of our customers, a large electronics manufacturer, had upgraded to from the 10.202 patch set to 10.203, and they ran into an optimizer bug after that upgrade. And this can happen, a query plan change, and that query plan affected a query that was used very frequently in running their manufacturing lines for their most important product. And what this meant was their manufacturing line slowed down and they were delivering less product and therefore making less money, which is obviously a very big problem. Well, they had filed the SR and the optimizer team was looking at it, but wasn't going to be able to deliver a fix fast enough. So after about 3 days, that customer decided they needed to go back to the old version of the database because they had 3 days of manufacturing and logistics information that they couldn't rebuild if they had gone back to their pre-upgrade state. So what do you do if you're in that situation? Well, we have 3 options for you here. Data Pump, GoldenGate, and Downgrade. So first of all, you can go backwards with Data Pump export import. You can go all the way back to 10.1 if you want to. Now, the way you do this is a bit different than the old original export import used to work. In Data Pump, there is a version parameter that will allow you to export and create a dump file that is compatible with an earlier version of the database. And this can be any version at this point. Originally, when we came out with Data Pump, we thought we might restrict this to going back only 1 or 2 major versions. But even now, with 18C, if you really wanted to, you could produce a 10.1 dump file using this. Now, when you perform this export, Data Pump will skip any elements in the database that are not compatible with the old version. For example, if you had a table using extended varchars, which were added in 12.1, and you exported saying version equals 11.2, then any table with an extended varchar column would be skipped, and you'd have a message in your log file indicating that. So what you can do is export from your current database, import into a database with the old version, and get back up and running. And you can even do this over a network link. So that means you don't have to manage a dump file. So that's all well and good. Just remember, you're limited to the features available in the earlier version of the database, not just for database features, but for Data Pump features as well. Now, the downside to downgrading with Data Pump is that it could be time consuming. If you have a multi-terabyte database, you might be looking at an hour or more to perform the export and import. And often a downgrade situation is kind of an emergency, and you want to get it done as quickly as possible. So in that case, you might add GoldenGate to the fallback scenario. There are a couple of ways you could do this. If you have upgraded and migrated to new hardware to begin with, then when you start up that new version database on the new hardware, you can have GoldenGate replicating backwards to your original source database. GoldenGate can replicate from a higher version to an older version, and like Data Pump, it will be limited by the features available in an old version, but this can get you back to the old version basically within a couple of minutes if needed. The key to using GoldenGate for a fallback strategy is that you want to have it implemented right as you upgrade, because you don't want to be sitting there with your upgraded destination database that has some sort of issue that is motivating you to fall back and have that be the first time you've set up GoldenGate on that database. You're going to need to know whether you have primary keys on the right tables or what other restrictions you might have, whether it's data type in the old source version or other restrictions that may need extra work. Another way you could use GoldenGate in a fallback is combined with Data Pump. If you have your upgraded destination database, let's say you upgraded from 10.205 to 12C, and you need to downgrade, but you don't want to go all the way back to 10.205, so you use Data Pump and maybe go back to 11.204. Well, you could do that export and import while you are capturing changes with GoldenGate and kind of limping along with your newer version database, and then replicate with GoldenGate back to 11.204. Once you've caught up, you could do the switch back to the old version. But again, you want to make sure that you have GoldenGate configured on your upgraded database initially, if that's part of your fallback strategy. Now, the final method we have for going backwards is what we call downgrade, a often tested but rarely used technique for going back to an old version. In all the times that Mike and I have talked to customers, whether it's for customer engagements or even during our upgrade workshops, probably with more than 10,000 customers we've talked to over the years, I think we've counted 14 customers that we know of who have downgraded a production database. But it is there. We test it for every release, and it does work. You can downgrade as long as you have not changed compatible. So that is, again, the restriction, and that's why we talk about the compatible setting earlier in this little presentation. The way downgrade works, just the high level, is that if you have a database that you want to downgrade, so you've upgraded to 12.2, now you want to go back to 11.204, you shut down the database and start it up in downgrade mode. Then you run the cat downgrade script, and that will undo most of the upgrade actions that were performed when you upgraded to 12.2. And then you shut down, start up in upgrade mode in the old environment, say 11.204, and run cat reload. That will make the dictionary again an 11.204 or whatever version you're going to dictionary. Now you'll notice I use some kind of weasel wording in there saying that cat downgrade undoes most of the upgrade actions. And the reason for that is that when we run the downgrade, there are certain actions that we don't completely reverse. For example, if we add a table to the dictionary during the upgrade, then on downgrade, we tend not to drop the table. Instead, we will truncate it. The reason for that is that we want the downgrade to be as fast and efficient as possible. Again, because a downgrade is usually a fairly an emergency type of situation. And if you drop a table, you have logging, and it can take a lot longer than if you truncate the table, which is a very fast operation. That's just one example. The other thing to note about the downgrade and reload scripts is that they are not parallel. Unlike the database upgrade scripts, these are still single-threaded SQL scripts for downgrade and reload. So if your parallel upgrade had saved you 20, 30, 40% on upgrade performance, you may see that the downgrade will take a bit longer than your original upgrade. One last slide about fallback is multi-tenant considerations. In a multi-tenant environment, we need to remember that pluggable databases always take on the compatible setting of the root container. So you can't have a CDB that is at compatible 12.2 and a PDB that is at compatible 12.1, for example. So while we do support downgrade of PDBs, this is only possible if you have upgraded without raising compatible. And this is true also if you're doing an unplug and plug. So let's say you have a 12.1 container database, you create a 12.2 container base, you unplug from 12.1, plug into 12.2 and upgrade the PDB there. If that 12.2 container has compatible set to 12.2, then you won't be able to downgrade that PDB. So that is one consideration. Another is that the guaranteed restore point flashback database is available. It is available for individual PDBs, but only starting in 12.2 when we have local undo. So if you want to use flashback database in 12.1, you're going to end up flashing back the whole CDB and all of the other PDBs. That to me means that's not all that useful if you have multiple PDBs in an environment. Because if you're sitting there in PDB number 3, you might get pretty cranky if the entire database gets flashed back just because someone in PDB 12 did something wrong. The other thing to note is when you're moving to a new version and say you migrate from a non-CDB to a PDB, that conversion is not reversible. The non-CDB to PDB script, which does the conversion, there's no equivalent PDB to non-CDB script. Well, if there is, it's to use data pump or especially full transportable to migrate into a non-CDB. So that's our talk on fallback strategies. If you have any questions about that, please enter them into the chat, and we'll certainly address them. I'd now like to move over and talk about some of the couple of customer questions that were sent in earlier via the AskTOM interface. Now, the first question is about DBUA versus command line for upgrade, asking whether there's a decision flow chart with pros and cons for the upgrade methods. Now, I'm going to take this to mean the upgrade methods being DBUA versus command line. We do have white papers actually about how to choose the right upgrade method, which also address things like data pump, transportable table spaces, in addition to command line upgrade and DBUA. But for this, since the question came in really kind of looking like it was talking about just those two upgrade methods, we'll focus on that. And the answer about which is more frequently used, more stable, more efficient, it all goes back to the usual answer of it depends. And as I mentioned here, in our surveys, and we often will ask about this when we do an upgrade workshop, we'll ask our customers how many use DBUA, how many use command line upgrade. I would say of that mix, about 80% of our customers like command line upgrade, and maybe 20% will use DBUA. And it's for various reasons. A lot of times, people who don't use DBUA was because when they've used it, they've had issues. Other times it's because they just like the extra control that command line gives you, and so on. But let's compare them. So if we compare command line versus DBUA, I didn't bother with a build on this slide, but you can see all of the different aspects here. On the one hand, you have just the command line versus the GUI motif. Some people just really don't like graphical user interfaces for administrative jobs. And that might be true that they don't like DBUA, they don't like Enterprise Manager, they want to be able to issue the commands themselves because the nature of a GUI is that it hides complexity. That can be viewed as good in many cases, or it can be viewed as limiting in other cases. One of the things that DBUA does for you is it integrates all of the steps of the upgrade, including the pre-upgrade, the post-upgrade. And it can also do things like time zone upgrade for you. On the command line, the pre-upgrade is a separate script. That can be good or it can be bad because one of the restrictions of DBUA is that you need both the old and new Oracle Home available when you use it. The reason for that is DBUA works by starting the database in the old home, running the pre-upgrade script, allowing you to maybe make some changes via the GUI, and then it shuts the database down and then moves to the new Oracle Home and upgrades there. And that's all great unless you're moving to new hardware, because when you move to new hardware, you're not generally installing your old Oracle version just to do the upgrade. And in fact, you may have situations where the new operating system on your new server doesn't even support the old version. So that could make it very difficult to use DBUA. So again, there's pros and cons there. On the command line upgrade, the user will control all of the parameter values, including things like where are we going to put log files? What is the degree of parallelism in the parallel upgrade? In DBUA, you don't have control over that. There was a time when DBUA allowed you to control the degree of parallel, but that is not the case anymore. The command line upgrade is restartable if the upgrade fails for any reason. And we've seen lots of reasons that upgrade could fail, often not having to do with the upgrade. And contrast that with DBUA, one of the customers I talked to just within the last year had an issue where they were upgrading using DBUA and it was in a VNC session and the VNC session disappeared. The VNC server crashed. Now DBUA, the upgrade failed. You couldn't restart the upgrade using DBUA. Even in that situation, you can restart the upgrade using the command line. The logging on the command line upgrade is much more robust than DBUA because for whatever reason, the database upgrade assistant sets echo off in your log files. That means in DBUA logs, you will often find things like statement processed, statement processed, statement processed without telling you what the statement was. So that makes it more difficult to diagnose issues when you're running DBUA. So I think that pretty much covers the comparison between command line and database upgrade assistant. But there is one other thing that DBUA can do that command line upgrade doesn't do, and that's to run in silent mode. DBUA does have a silent mode where you can either provide all of the parameters on the command line or in a response file, and that allows you to run the upgrade and post-upgrade, all of that with one command. It still has all the limitations that you have about DBUA, such as not being restartable and requiring both Oracle homes. Well, just as a little tease, I just want to mention that we are working on that for the command line upgrade. We have some ideas for how we are going to take the best of both worlds and make command line upgrade even easier while giving you all of the control that you want and currently have for that command line upgrade. So all I'm going to say about that is stay tuned. We will be talking about this later in this calendar year as it becomes more public, and I think you're going to be very impressed with what we come up with. So the last customer question that we have submitted has to do with restoring a database from an earlier version into a newer Oracle home. And as you can see here, this customer, when they tried to open the instance with an Ultra database open, they get an error saying there's a bootstrap process failure, invalid identifier, and in this case, there was a field in tab dollar that is not valid somehow. So what happened? Well, I think what happened, and this is kind of speculating based on what we have in this question, but I'm pretty sure what happened here is a case that is not uncommon. And that is that when you restore an older version database with a newer version of RMAN, that will work. And it's a great way to migrate to a new server and then upgrade the database. But you do have to upgrade the database before you open it. If you look in the answer here, I reference this note, frequently asked questions about restoring or duplicating between different versions and platforms. And let me show you that note here. We'll go to my Oracle support session. And of course, it's timed out on me, so it has to reload. But in a nutshell, what happens is when you restore a previous version database using a later version of Oracle, it very clearly states that after you restore, do not open the database at that time. You then have to manually upgrade the database, they are saying in this case 10.2 to 11.2, before you can open it. So that's probably what's going on here. And if the person that entered this, if that's not what happened, then by all means let me know. But this is something that has confused customers for a long time. RMAN does not perform the upgrade actions when it does the restore. That's really all you need to know about this. This is a question about XTTS migration from 11.2 to 12.1. Yes, oh no, XTTS is definitely supported. And you may be referring to what I just said about RMAN. One thing to note about cross-platform transportable or transportable in general is that when we perform that kind of migration, we have to import the metadata for the database into a new database. So that means that that's different from RMAN. So when RMAN does a restore, it's physically restoring your system table spaces. And that's why you would need to upgrade before using the database in the new version. With transportable table spaces, we're bringing all your user table spaces over, but you have to create a new database with that new version and then import the metadata into it. So you can actually use transportable table spaces to migrate a database from 8i all the way up to the latest version if you're on the same platform, or from 10G up to the latest version if you're going cross-platform. Oh, how to show patches that are in the database. There is a way to do this, and I will have to fumble around a little bit in the database to show it. Mike, do you have the that information offhand about which it's registry SQL patch or whichever view that is?
Yes, of course. I'm just going through the block. and I will paste it in a second into the chat window, so I have it already in the background. So basically, first of all, for the binary, the easiest way is opatch ls inventory, and this tells you which patches are applied to your database home binary-wise. There's another way with dbms qopatch. That's a package in a database since 12.1, which allows you to query the same information, and I'll post a link in the blog in the chat window in a second as well. And when you are connected to the database, then there are basically two views. One is DBA_registry_history, and that is not used in most versions, but DBA_registry under a SQL patch is used. And I will paste this link here in a second into the chat window as well. Where's the chat? Here's the chat. Oops. So first of all, this link here tells you the difference between the two views and gives you access to a script as well. And the script can read the patches from the database. So it's the difference here in 11, if Roy scrolls down a bit. So this is DBA_registry history, and the query looks a bit different. And it goes basically into DBA_registry_SQL patch. And the history should be maintained as well, but there is still issues. And I think with 18C, that should be now finally maintained again. But in 12.2, I think the history in 12.1 was left out. So it's a tiny little script, and this will tell you if you have really run the cut bundle patch script in 11, or the data patch minus verbose in 12. So opatch ls inventory on one side to check binary, and on the other side, the check patches script from the blog here will tell you if the patch scripts, which usually come with the patch, have been applied to all your databases as well.
And that's a very good question, because it is not uncommon when we have an SR raised, for example, and the customer says, I applied this patch, but the problem still exists. More often than not, what has happened is they've applied the patch to the Oracle home, but not run data patch on the database. So this is very useful to know exactly what patches are installed in your database. It's also useful when you go to upgrade to know what patches are in your database, because you may want to find out whether those individual SQL patches are actually fixed or included in the new version or in the newest release update. And this is the other one, DBMS QO patch. So one of the things, I just want to go off a little bit about DBMS QO patch. This was a new package that was added to 12.1, and it has some pretty useful features in it. And one of the things, for example, that I have an enhancement request filed about that I assume will get worked on eventually is one thing we can do with this, for example, is when the database starts up, it could check to see whether all of the patches that are in the Oracle home have been applied to the database, and then issue a message to the alert log if that has not taken place. And that would be a way to proactively, from our side, proactively tell you, hey, wait a minute, you still haven't run data patch on this database. So if Aura Home April 17 has a PSU from April, and October has October 17, and you create a blank database on each of those two Oracle homes, how can you show that these two databases differ in terms of bugs fixed? I think that we just showed that with these queries. And you could query across the two databases, of course, and do some interesting SQL to say, you know, select from the registry, the registry DBMS SQL, DBA registry SQL patch where, you know, it's not in, select from the remote over a DB link. That's a good question.
And one important thing to mention, because I blogged about this as well today, when you create a fresh database, it really depends when you apply the patch before. If you use and create the database with DBCA, or if you create it with a script. So whenever you create a database with your own scripts, you must run either cut bundle for 11 databases or data patch minus verbose for any 12 database you create by yourself or 18C. When you use the DBCA since 12.2, the DBCA after fresh creation of the database calls data patch minus verbose by itself, but before 12.2 it didn't call it. So whenever you created a 12.1 database, you had to call data patch minus verbose by yourself, because otherwise you had a mismatch. You were using the fresh binaries already, the patched binaries. Let's say in your example, the April or October 2017, but your database didn't see the SQL changes yet. It's not that bad. It's just a little bit of inconsistency. And the next time you apply one, that gets flagged by data patch. So let's say a month, 3 months later, you apply the next bundle patch, and then you run data patch verbose, and it will flag that and tell you, and usually fix it up afterwards. But be aware of that. Just wanted to add this.
Great.
And it's exactly what you're right here in the block, the Dear DBA. This is exactly what happens when you, I assume you're on a 12 database, and this is when you applied only the binaries, but you never run data patch verbose. So in this case, it's very simple. You run, you go to your opatch subdirectory, you run data patch verbose, as Roy shows here on the screen here, Oracle Home opatch data patch verbose. It will pick automatically your database, assuming that the Oracle SID is set and the home is set correctly, and then tell you that the scripts are missing and run it in your database. This is an action which happens online. So you don't have to shut down your database. You don't have to bring it into startup upgrade mode or whatever. So you can simply do this now, actually.